What's up, YouTube? I think that we are live. Let's freaking go. My name is JC Practices Math, or you can call me John if you're a normal person. We are going to be practicing linear algebra today. I'm working out of Frale, and I'm trying to solve every single problem in this book and share the process and hang out with some fellow math nerds on YouTube in the process. So this is a live stream. If you've clicked this, I hope that it's still enjoyable after the fact. Like, it's not just only interesting if you happen to tune in live, but it is especially fun if you do get to stop by. So I don't have a schedule yet, but it's looking like it's kind of like 8 a.m. weekdays Eastern time in the U.S. I'm based on the East Coast of the U.S., and so I think we're 5 hours behind UTC, so that means 1 p.m. UTC. Anyways, enough chit-chat, enough yapping about that. As a live stream, there's going to be pros and cons. An amazing pro is that, just generally speaking, it's just fun. If you can stop by and hang out and say hi, it's really great. Like, especially that I can get feedback from you all in real time. I can put you on the spot as a chatter. I'm like, hey, should I do this or that? How can I make this stream better? Like, what would you like to see in a math practice stream? So that's a nice thing. So Frale 1.3.4, we are trying to compute A plus B, where A is -2, 1, 3, 4, 0, 1. My passion is really to introduce people to a lot more math. Like, a lot of people think that math is done, or that they've seen math because they took calculus. Bro, you don't know. Math is not done. There is so much math out there to learn. And if you've learned it all, guess what? Invent some new math. There's so much freaking math that's possible. And for some nerds like me, it's just fun. It's like a Sudoku. So I like to call myself a hobbyist now. I'm just doing math recreationally, just for fun, just for funsies, just because I can't stop. I have to do math. And yeah, for some people like me, it's just fun. You don't need an internet connection. You don't need Chat GPT. You don't need any of that nonsense. You can just have a piece of dead tree paper. You can have a notebook, a physical notebook and paper, and write with a pen on paper. It's just so nice to get away from screens sometimes. So let's do this on this fancy iPad. When we're adding matrices together, you add the elements of each matrix. So, for example, this last element that I'm writing is going to be 1 plus 3. Boom, done. All right, now, part of my goal with how I'm working through this book and relearning linear algebra is going by sections. So next section is going to be 1.4.4. I'll do the first problem from the first section, the first problem from the second section, the first problem from the third. So I'll take one problem from each section until we get stuck. And if we get stuck, then I restart. And then that way I can just talk about a lot of different topics in one sitting. And a nice little side effect, a nice little byproduct of that is that if you are tuning in and this is your first time learning linear algebra, you might be able to follow along with the early sections, and then at some point we lose you, and that's totally normal. The whole idea is that I'm going to keep going. I'm going to work some easy problems until I get to some hard stuff, and then I get stuck. So I am very passionate about vulnerability and authenticity as a practice streamer. So because it is a practice stream, I will be making mistakes all the time. And So, you know, that's one of the pros and cons. If you want to see somebody making mistakes, doing mathematics, I'm your guy. If you want to see perfect mathematics, I don't know, go watch Khan Academy or something, dude. We've already done it. We already have perfect explanations of math. It's all been done before. Now, what you can get instead is somebody who's just like yapping and ranting and like trying to promote his like freaking classical guitar practice stream. I'm also a classical guitarist. JC Practices. If you want to go follow my guitar channel, it's a pretty good time. It's a nice little community. So to find row echelon form of a matrix, this is not unique, but reduced row echelon form, a benefit here is that it is unique for every matrix. But we're going to do operations one at a time. One operation we can do on this matrix is to swap two rows. Maybe I'll swap the first and or the third and first, right? 0, 0, 3, -2, and then I'll keep the second row the same. I bet you've never seen multiplication and addition of blocks of numbers. Most people haven't. It's called linear algebra. It's what drives ChatGPT. So, if you want to learn machine learning and linear algebra, or if you want to learn AI, linear algebra is your best friend. It's the way to understand AI. So now the last row, we're going to subtract 3 times the second row. So 3 minus 3 is 0. -2 minus 6 is -8, right? This is now in row echelon form, right? And it's not unique. There's other ways I could have done that. But now the last row I'm going to divide by -8. And then I'm going to subtract this row from the other ones. So there's kind of some ... steps in here, but I'm going to go ahead and take the shortcut. So here, I'm going to subtract 2 times the last row from the second row, and then I'm going to zero out these entries above. So 1, 3, 0, 0, blah, blah, blah. This is it. This is the reduced row echelon form. So we're done. And this is crazy. College John would have been offended by this. This is a pen, and this is my textbook. And I'm going to cross out this problem. Boom. Permanently marked, permanently crossed out. I know. There should have been a trigger warning for that. All right, F&B 1.5.4. Let's keep going. Frale and Beauregard. This is my favorite linear algebra book so far. I tried Strang. I didn't like it. I hear that the videos are better than the textbook, but, you know. I'm going to reword this problem statement. So we're on 1.5.4, 6, 7, 8, 9. 6, 7, 6, 7. Do you think that was on purpose? Dude. All right, 6, 7. We have, the game here is to go from A, adjoin I, do a bunch of row operations, and then, if possible, find the reduced row echelon form, RREF. If the reduced row echelon form of this augmented matrix has I, the inverse matrix on the left, then the right-hand side is the inverse. of A. So we've got 6, 7, 8, 9. Append 1001. All right, I don't want to deal with fractions, so I'm going to take, this is kind of painful, but, all right. What's the LCM of 8 and 6? You know, the naive way to do this would be, what is it? 48? But that's not true. It's not 48. The LCM is 24, right? So I can do 4 times the first row. I'm going to keep the first row the same. 1, 0. And then I'm going to do 3 times the second row minus 4 times the first row. That way we get 24 minus 24. We get a 0 in that first one. And so we have 27 minus, 27. Let me put on my teacher hat and show you all the intermediate steps so that we all can follow along. 3 times 9 minus 4 times 7, right? 3 times 9 is 27. 4 times 7 is 28. So here we go. This is -1. And again, this is 3 times... Oh, geez. If we want this as a product of elementary matrices, I can't take this kind of shortcut step. I have to show the steps in between. So, sorry. Pause. Slow down, John. Slow down, John. Because an elementary matrix has a certain definition, and I was already jumping to like the combination of 2 operations. So first, yeah, let's slow down. Slow down. We're going to quadruple the first row. So 4 times 6 is 24. 4 times 7 is 28. 4 times 1 is 4, and 4 times 0, luckily, is 0. We'll keep the second row the same. I was jumping ahead to doing a couple things all at once. Because, you know, that's how you do it in the real world. You just go straight to, you know, 4 times this minus 3 times that. 24, 28, 4, 0. So I'll keep that first row the same. And then now we triple the second row. 24, 27, 0, and 3, right? Now I want to take the first row. I wonder if I'm being overly technical, overly pedantic here. I don't know if it's... Can I... I'm going to have to read the section to check. I don't know if this step is... I don't know if I'm overly doing it in the pedanticness. All right, so second row minus first row, 24 minus 24, 27 minus 28, 0 minus 4, and 3 minus 0, right? Now we can go 0, 1, 4, -3. It's worth doing this once in your life and then promptly forgetting it or promptly skipping a lot of steps. Now we can divide the first row by, I guess we'll just go ahead and go straight to yeah, I'm confusing myself. I think I'm doing one too many steps in the thing, whatever the thing is. You know what I mean. No, you don't. Let's divide by 4. So 6, 7. Oh yeah, there we go. 6, 7 again. There it is. Now I feel better. And 0, 1, 4, negative 3. I'm showing every single little step, and I think that this is overkill. I don't think that this is necessary. 0, so I can multiply this row by 7, and then now they match. 6, 7, 1, 0. And now I can subtract the second row from the first row. 6, 0. 1 minus 28 is negative 27. 0 minus 21 is 21. Right? And then keep the second row the same. 28, negative 21. I'll divide the second row by 7. Keep the first row. Yeah, this is overkill. This is super overkill. I don't think that this is necessary. 1, 0, negative 27 sixths, and 21 divided by 6. Right? And now we're done. We can do a little simplification here. 27 is not divisible by 6, but it is divisible by 3. So 27 divided by 3 is 9. And same thing, 21 and 6 is 7 halves. Right? Okay. So, 2 steps. First, it also wanted me to write down what the elementary matrices are for every step here. For example, if I did this correctly, so we scaled the first row by 4, then we scaled the second row by 3, oh, it's kind of meditative, but I'm going to save some time. How many are there at least? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 in total, and the last operation we did was dividing the first row by 6. Right? I don't understand this, but came for the vibes. Hell yeah, dude. Hell yeah. That's the goal, man. I want to be able to practice math, and even if people don't know what the fuck I'm doing, like, if people enjoy the vibes anyways, like that, dude, that would be so sick. Are you a math kind of person? Do you know any kind of math? What's up, Keto the Great? How are you? Okay, so now, 2 things to verify. We can check that A inverse is I. This is kind of like, what is the inverse of 2? Well, the inverse of 2 is 1/2. If you multiply the 2 times 1/2, that equals 1. This is the same idea, but it's in matrices instead. So this is one thing that we can verify. And then the second part, Freeberg wants us to write A inverse as E9 ... E2 E1. Like, if you multiply all of these individual steps, that it should equal AI. Not AI, A inverse. This is an exercise for the reader. I'm not gonna do that. That sounds boring as hell. Let's at least do. Where is A? 6, 7, 8, 9. Do you think that was on purpose? 6, 7? 6, 7, 8, 9, multiplied by -9 halves, 7 halves, 4, and -3. So I bet you've never seen multiplication of blocks of numbers. This is multiplication. It's just fancy multiplication. Okay, so this is going to be a few different numbers. I'm going to write it this way for a second. Where A11, like the first number is going to be 6, 7, 6, 7, dot product with -9. It's easier to see it this way, even though this is kind of an abusive notation. Bonjour, hey, what's up, SB? What's up, Sid? Sid, comes from my guitar stream, everybody. It's freaking sick. What's up, man? So we are going to do the dot product of these two vectors. We kind of do multiplications of a row and a column. So this is 6 times -9 halves plus 7 times 4. Why do I feel like I got this wrong? Oh, no, I think I did it fine. All right, so 6 divided by 2 is 3, and then 3 times -9 is -27. And then 7 times 4 is 28, so this is 1. So, hell yeah. We're on a good path right now. That one is 1. Not much. How about you? I'm chilling, man. I did some interview practice. The only kind of practice that I should be doing, because I need to get a new gosh dang job. I did a bunch of interview practice this morning. So that was cool. All right, we're going to do 6 times 7 halves is 3 times 7. That's 21 minus 21, and that is 0. Hell yeah. Hell yeah. Now, oops. Getting used to the iPad tricks again. Let's do, I always do them in this order. So 8 times -9 halves is going to be -4 times 9, which is -36. And then 9 times 4 is 36. So, hey, look at that. That's 0 as well. And now, finally, we're going to be doing yoink. Move that right there. 8. So this is going to be 4 times 7, which is frickin' 42. Oh wait, what? No, what am I talking about? 4 times 7 is 28. And then 9 times -3 is -27, right? So 28 minus 27 is 1. And then voila, we indeed got that to work correctly. I have to pee, so I'm gonna be right back, y'all. I'm gonna be right back. Yeah, you can send the picture. I probably won't work it, Siddharth. just to be totally honest with you. But yeah, you're welcome to send it. All right, be right back. Check out my guitar. What's up? We're back. Yo, JC Practices. Welcome to the channel, dude. Welcome to the channel, bro. I like your handle. Mine is JC Practices Math. JC Practices, you need to be a little more specific. What do you practice? What specifically do you practice? I'm practicing mathematics. Hello, everybody. Welcome back to my practice channel. So we are working on matrix multiplication. We just worked Frale 1.5, was it? Have we already done 1.5? Yeah, we just did 1.54, and I did 1.53 the other day, so now we're going to go to section 6. We got homogeneous systems, subspaces, and bases. We're getting into some cooler stuff. I mean, all this stuff is cool. All this stuff is very cool. Linear algebra is actually one of my favorite math subjects, everybody. Maybe it's just nostalgia, but it turned me into a math major. By the way, did I mention I studied pure mathematics? Pure mathematics back in the day. So number 4, we have the set of xy such that xy are real numbers and xy are both positive. And it has this nice little parenthetical. The first quadrant of R2. Is this a subspace of R2? The answer is no, because KV is not in the S for all K in the real numbers. For example, -1 times 1, 0 is -1, 0, which is not in our set. So, we're done. Frale and Bjerregaard 174. FNB 174. Good morning. What's up, Leo? How's it going, dude? Welcome back to my practice channel. Leo, what are you practicing these days? Siddharth over here, SB Practices. He's such a super fan of my guitar channel, especially, and he's also a math dude, which is cool. He's such a fan that he changed his YouTube handle. So, Leo, if you ever wanted to become Leo Practices and create your own practice stream, dude, I would love to see a Leo practice stream. Just like you at work, in the trenches, more focused than I am, actually freaking thinking out loud as you're, like, working on whatever the hell you're working on. I'm not gonna lie, I really like practice streams. I think that they're fun. They feel way more productive to me than most YouTube stuff. Like, you don't have to video edit, and most of the time you're like freaking actually doing the thing. Like, you're actually practicing, you're actually studying or practicing the guitar or whatever. Okay, so is this matrix 0.1, 0.2, 0.3, 0.4, 0.6, 0.4. Here's the problem. If you're watching the VOD after the fact, please pause the video right now and try to solve this problem on your own. That way you don't have to buy this book. Just pause the video and just solve the problems with me. All right, let's go. 1, 3, blah, blah, blah. All right, so the sum of the entries in column 1 equals 1. And for column 2, it is also 1. And it is true that there is m greater than or equal to 1 such that a to the m has no 0 entries. Really just a to the 1. Therefore, it's regular. Tropical geometry. That sounds cool. Right now I'm trying to beat a Minecraft hardcore. Is that a thing? A Minecraft hardcore? Like, is that like a hardcore level of Minecraft or something? The questions in the in the math Discord chat. Leo, I don't know if you use Discord, but dude, I have a Discord server with a math channel. If you ever wanted to chat math there. It'll take like a second to solve if you know what to do. I don't want to do it right now. Learning information theory / quantum complexity theory. That sounds sick, dude. That sounds really cool. Yeah, tropical geometry sounds awesome. The thing about math that is like so fun for people, I think, like definitely like me and maybe like Sid here and probably Leo, I'm guessing, is just like the names of these things. Like, what the fuck is tropical geometry and why is it named tropical geometry? Like, what are all these weird names? Like, what are all these different subjects with the coolest sounding names? Like, let me flip to a random page here. Algebra of complex numbers. Okay, that's actually, I know that. But that, I mean, like, imagine that you don't know what imagine you don't know what complex numbers are. Like, complex numbers? Like, how, like, what do you mean? Like, how complex are we talking about? Complex means hard, right? Like, and what's like, algebra of complex numbers? The LU factorization. That sounds cool. Coordinatization and change of basis. None of this is a diagonalization. That is a cool word. Like, you just hear that you're going to learn about diagonalization. Like, what does that mean? Yeah. There's something about math that's just so lovely there. Normal geometry operations plus x, then tropical geometry is geometry with min and plus. That sounds cool. Connects to a lot of deep stuff, a lot of hard algebraic geometry stuff turned into simple things in tropical geometry. Bro, that sounds so cool to me. Similarly, many optimization problems in computer science can be phrased as tropical geometry problems. Yeah, Minecraft hardcore run. Use Discord intermittently. No idea why it's called tropical geometry. I would not be surprised if this was named on a whim. Just like, why not? We're running out of good names. Why not? I wish I were in the Bahamas right now or something. Like, dude, that sounds awesome. The Bahamas are not tropical, are they? But whatever. Yeah, you get what I mean. I wish I were on vacation. Alright. Fräulein Biergard 1.8.4. What do we have in this next section? We are talking about Hamming codes and error correcting codes. This is a cool optional section that my class didn't do back in the day. So in this problem, I might have to read the section for this one. 100110. But I've started learning it because we've done a few laps through this chapter. 0 1 0 1 0 1 0 0 1 0 1 1. So this is a generator matrix. And last time that I was working these problems, the last problem about this is, we did it over here. And the question was, give the parity check equations for this code. Given this generator matrix, give the parity check equations. So Hamming codes are these self-correcting codes or error-correcting codes. And my favorite analogy is credit card fields. So like when you type in your credit card in the Lyft app, I know this for a fact because I worked on that app. I worked on the payment system. I worked on that exact text field. The app can check to see if you made a typo without sending your credit card information anywhere, because it uses these things called parity checks. So this isn't correct, but they're very well known what the credit card parity checks are. But you know, a simple rule on credit card numbers might be that there should be the same number of even numbers and odd numbers, right? So if you type in your credit card and there's more odd numbers than there are even numbers, then it's like, yo, I don't even need to read these numbers. I don't need to like look this up in a database or anything. I know that you made a typo because they don't match, right? So that is the idea. In Hamming. I keep mixing up. Who the hell is Huffman? Is that a math textbook author? Hoffman and Kunz? I don't know, whatever, it doesn't matter. This generator matrix says that if you have a 4-bit vector, then we can add these extra bits that will give us a little bit of redundancy, but it'll give us some checksums. Like you use the word checksums. So in this case, x5 is x1 plus x2. X6 is x1 plus x3. And x7 is x2 plus x3. So, if somebody was trying to write down the code 1011, but they made a typo and they accidentally typed 0. I don't know. You know what? I'm going to just pause here. Like, you convert this. Well, let's do it. Why not? 1011. The 5th bit would then be x1 plus x2. The 6th bit would be x1 plus x3. And then the 7th bit would be x2 plus x3. Right? So what's wrong? Oh, wait. Oh, the problem is that this is a Hamming code for 3-bit numbers. So here we go. Now this is fixed. I was like, something is wrong. Yeah, this is the generator matrix for 3,6. Instead of sending just the simple 3-bit word 101, instead you send this whole thing. And if somebody makes a typo or there's a cosmic ray that flips one of these bits, if you received 01001, maybe this bit was flipped to a 0, we would see that this is unexpected. And we would say that the person probably meant 101101, which is expected. And then that maps to the real message that you tried to send was 101. But because of this like little extra information and the fact that this 0 does not match this expected 1, then you can correct that message, even though your computer accidentally wrote something to your SD card incorrectly, or somebody made a typo, or a cosmic ray or something. So like, are you going to become a prof? No. Hell no, that sounds hard and like not a lot of money. That sounds like a hard life, especially at my age. But I would love to be a YouTube professor, like in some way, like just practice and learn math and teach students privately, like get some private students through YouTube practice streams. Bro, that would be a dream. That would be awesome. Huffman codes are yet another code. I thought so. I thought that there was something else called Huffman codes. Okay, Hamming codes. Got it. Oh, maybe you were asking, Sid, maybe you were asking if Leo was going to be a professor. Got it. Yeah. Leo probably will, because that's the only thing that an advanced math degree really prepares you for. Not really. Software, a lot of people go into software, finance. The 3 bets are Leo goes into software, finance, or academia, or teaching of some sort. All right, anyways, so this was just some review. 1.8.4 actually asks, list the code words in C. Okay, this is kind of tedious, but it's not so bad. It's not so bad. We can do this. So, we're going to list every binary number with 3 bits. Which we can do like this. Okay, so there should be 8 in total, and there are indeed 8. And now I already wrote this down preemptively. Doop, doop. And we can just write down, so I said x5, x6, and x7. What I meant to say was, let's just rewrite all this. x4, x5, and x6. Okay, so x4 is 1 plus 2, the first and second. This one is the first and third. Wait, what am I doing? Let's slow down, John. Okay, this first one is definitely going to be that. The second one, x4, is the first and second. X5 is x1 plus x3. And then the last bit is the second plus the third, right? I'll get the hang of this, but I'll do the 4th bit for all of them first, so I can just keep that rule in mind. 0 plus 1, 0 plus 1, 1 plus 0, 1 plus 0, 1 plus 1, and 1 plus 1. Now we're going to do x5, the first and third. 0 and 0, 0 and 1, 1 and 0, 1 and 1, 1 and 0, 1 and 0, and 1 and 1. Okay, and now finally the 6th bit, the second and third. 1 plus 0, 1 plus 1, 0 plus 0, 0 plus 1, 1 plus 0, and 1 plus 1. All right. Something feels off that this is 111000. At least the other time, 111 mapped to 111111. So let me just double check myself there. Oh, wait a minute. In binary addition, I think addition is defined as 1 plus 1 is 0, right? It's not addition like the plus meaning the or sign, right? Am I dumb? Am I a dummy? Am I a dummy? Adding mod 2. Yeah, 1 plus 1 is 0. Okay, I got that right. I got that right. Okay. Okay, I don't know. Yeah, seems right then. Yeah. Cool. Okay, well then in the 7.4 code, we had this property. So I thought that might have always held that that a string of ones will map to a string of ones, but I guess not. I don't know. That's what you get if you assume things. 1.8.4, we just learned. I'm pretty sure that that's right. Now I have an option. We could go to chapter 2, or we could call it a day. It's been a 52-minute video so far. I think I'm tempted to say that we should just hang out for 5 minutes and just chat, and then call it a day and switch over to the guitar stream. So, credit card sum checks. I think credit card sum checks is a good analogy there, right? Like to give the idea of Hamming codes. I think that's a good idea. Like typos. You made a typo while typing your credit card number, and it just instantly turns red. Like, nope, something wrong. You made a typo. SSNs have no error correcting or cryptographic features to them while being very, very important. That is crazy. That's a good call out there, Leo. Like, yeah, you would think that SSNs would have some kind of safety encoded in them, like some sort of checksums or parity checks. Yeah, that's crazy. Almost got owned by 1 million mobs at once. What? Almost got 1 million mobs at once. Are you talking about Minecraft? Also, I'm doing a video on 3 theorems that underlie like 12 fundamental theorems in theoretical computer science, and Huffman codes is like the degree 1 case of theorem 1. I knew that Huffman codes are a thing. Can you try to explain to me like I'm 5, like a really smart 5-year-old? Like what are Huffman codes? Generalize them to polynomials, which also used in error correcting codes, and you get the general form. Or you could answer my question. Oh yeah, Sid, I could look up your question. Sure, why not? Did you just type it here? Good, yeah. I don't want to open Discord, dude. If each element of a second order determinant is either 0 or 1, then what is the probability that the value of the determinant is positive? Neat. Okay, so you're saying that we have a matrix with binary entries, right? And a second order determinant. Okay, so you're saying a second order determinant meaning a 2x2 matrix, ABCD, right? And I liked the notation in this one book that I was working. Shilov writes a determinant with vertical bars. So this is AD minus BC, right? AD minus BC, and if every element is either 0 or 1, so the possibilities, there are 2 to the 4 matrices of the form A, B, C, D with A, B, C, D all binary numbers, either 0 or 1, right? So, yeah, I think that there's 16 matrices. It's a probability that the value of the determinant is positive. I mean, if it's positive, then it's 1. So you're asking how many matrices have AD minus BC equals 1, right? If it's so if AD minus BC is 1 I shouldn't write in Z2 because the matrix itself is not, like, we don't have 1 plus 1 equals 0, right? So let's just be like a little more explicit. This is 0 or 1. Yeah. So then if AD minus BC equals 1, therefore AD has to equal 1 and BC has to equal 0. And then the only way that this happens is if A is equal to D and they're both 1, right? So then these are all of the matrices with 1 in the first and last entries, and then either B or C is 0, right? So we've got that one. We've got this one. We've got this one. And those are it, right? Yeah. Right? Oh, why am I feeling a little blank? Okay, I think that's right. Yeah, they're both 0 or one of them is 0. So there are 3 out of 16. I think that's the probability. Did I get it right? If you add 1 to your SSN, it is another SSN. Yeah, like, I've always thought that SSNs are just naive, just like list. Like, the first person was 0001, the second person was 0002. I don't know how true that is, but that's how I've mentally thought of them. That can't possibly be true because of the number of digits, but yeah, 3/16. I got it. Yo, look at that. JC Practices, not stumped. JC Practices Math, not stumped. Hell yeah. And now Leo busts out some tropical geometry theorem that he's currently working on, and then I'm stumped. Just give me any problem, Leo. Give me any problem, dude. Stump me. What is the problem that's currently on your desk right now besides Minecraft? And then I'll officially be stumped and we can start the guitar stream. Just joking, don't worry about it. Let's go. So today, I had a lot of fun, everybody. Thank you for watching. My name is JC Practices Math. It is a shameless way to try to continue building my brand as JC Practices. I'm building practice streams. I also have a new gaming stream called JC Practices Gaming. So if anybody's interested in that, JC Practices Gaming, I am literally only playing music games, like Rhythm Doctor specifically. have any of y'all heard of Rhythm Doctor? It's so good. It's so good. It may or may not survive. It's a brand new YouTube channel, and it's hard to grow a YouTube gaming channel. I don't support video games of any kind. Thank you. That's a good idea. Yeah, don't. But I'm doing this for the sake of like fixing my rhythm. My teacher said, get the rhythm of a drummer. And I was like, yo, that sounds cool, but I'd rather play some music games on the internet, and maybe eventually it will improve. My rhythm could use some work too, TBH. Check it out, dude. Rhythm Doctor is so goddamn good. I'm very tempted to just practice it right now and show you all some Rhythm Doctor now that we're like an hour into this math stream and nobody watches any of these VODs for an hour straight. Can we play like a level, just like one level of Rhythm Doctor? Why not, right? Like, it's so good. Rhythm Doctor is insane. So it's a one-button rhythm game. You just press any button at the right time, and it starts really easy. You press on the 7th beat, but then it gets really, really, really hard. Like doing all sorts of like polyrhythms, like multiple tracks going on at the same time, offbeat rhythms and stuff like that. It's so good. It's like literally just my favorite game of all time, probably, because I'm a musician and I'm obsessed with music. All right, thanks for hanging out during the encore, everybody. Let's play some Rhythm Doctor. All right. Ah. Good enough. Let me know if you can still hear me. I think that you should be able to hear me. Let me know if the audio levels need to change or anything like that. Let's do a tiny bit. I feel like mixing in accents at different times over essentially the same rhythm is something I like to do. Interesting. All right, I'm gonna jump right to the very end. This is like one of the hardest levels. No. I wanna give you a good introduction to this game. Let's see. What's a good intro to this game? I'll just do the first level, just to like introduce, and then I'll show something a little crazier. Oops. I got distracted by the message in chat. Not perfect. Dang. Ah, okay. No excuses for that. Alright, no excuses. Whatever. Can't talk while doing this. Yeah. Alright.
A+.
Okay, I've definitely gotten perfect score on that one. So here's like a night level of the same. So there's like, this is a more difficult version, but it's still of level 1, right? So it's not as crazy as it'll get later, but this is like the difficult mode of the same song. this game has no right to have such an amazing soundtrack. Like, this game should not have such a great soundtrack through the whole thing. Whoops. Like, every single level is so good. Hell yeah. Hell yeah. So it's so cool because it just like intuitively introduces and teaches you intuitively, like feeling and just listening, feeling different rhythms. Like there's like 7/8 just thrown in there randomly. Yeah, it's so good. This game is so good. So I'll jump right to the finale. I failed like 5 times on that one. Have you tried playing it? Are you serious? You got the game, dude? Bro, Siddharth, I would love to see a Sid practices Rhythm Doctor. So I have not been able to solve this one. It's pretty cool. It's amazing, dude. This game. And it also has like a really cool, deep storyline. Oh, look at this. All right, you all get to see this insanity. So the game does this incredible freaking window dance thing. This is like, if anybody has like epilepsy, like please turn off your screen. Yeah, so I'm not going to bother fixing this right now. This is going to be crazy right now. We got OBS and the small window going. So the game like moves the window all around your computer. Oops. Yeah.
I've been searching for you. Need a sign, need a clue. No one else to turn to. I feel so lost without you.
I hear you calling me. Don't know where you could be. I wait here patiently, hoping that you will find me.
This is tripping me out because there's multiple windows and the zoom or the OBS infinity mode. This is insane. This is like next level, just Rhythm Doctor insanity right now. With OBS Infinity Mirror. Just fuck it, why not? That's sick. Yeah, this game is unbelievable. And the story is great, too. It's very heartfelt, actually. Okay. I'm done. I am done. Thank you. Thank you, everybody. Thanks for hanging out with me doing this crazy little Rhythm Doctor interlude or encore. All right, I'm going to practice some classical guitar. Thank you for watching. You can find me on the other channel if you just want to stop by, say hi, all that good stuff. Who knows? Maybe I'll randomly throw in some mathematics into the other channel too, in a similar fashion. All right, thanks for watching. I gotta go. Bye. Bye. All right, take care. Bye.